You need the right combination of the right hardware with the right software, because you can take the most powerful hardware, it may not work with the software that you are willing to develop, and the opposite is also the true. So the main challenge that they have is making the good match in between the two.
Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Hader. In today's episode, we'll dive into the complexities of embedded software development. We'll explore why software isn't just a commodity but a key asset, and why out of the box doesn't necessarily mean production ready. Joining us is Nicolas Duvernay, General Manager at Witekio, a company specializing in embedded software and IoT solutions. And Nicolas brings a wealth of experience in tackling the challenges of integrating embedded software into hardware systems, ensuring scalability, and maintaining security across platforms. So, without further ado, Nicolas, welcome to the show.
Thank you, Ruth. Yes, I'm Nicolas Duvernay. I'm the new General Manager of Witekio. Witekio is a software design house helping OEMs, device makers, to design, build the software for products of tomorrow, but even a lot for products that are already on the field. We are there for 20 years now. We have offices in UK, in France, in Germany, and in US. I would say we cover most of the West world. We were acquired by Avnet, just for the records, 5 years ago.
Terrific. To start us off, could you explain why embedded software development is so much more complex than many people would assume?
Software in general may appear complex. Not only embedded software, but software may appear complex when it comes to the different layers that are in a device. Embedded software could appear complex because you need to go into a very logical approach in the development. It's not like you can have creativity. While when you do software for the cloud, on the enterprise, which is much more common, I would say 98% of the developers in the world are doing what is not embedded software. Embedded software, in fact, from the history, is the software that goes inside the memory of the hardware platform, and there is a limited space. And so when there is a limited space, you cannot get so much creativity, and you have to make sure that it will never fail also. So it's very light code, and the code need to be almost perfect from day one, because now it's a bit different. Products are connected, so you can interact with them. But let's say until 5 or 10 years ago, the products were on the field and you have no possibility to interact. And if the products or the device failed, it was a big problem. Yeah, I would say complexity from this part of software development is coming from the constraints, coming from the memory where you have. So you cannot get so much creativity, and also there is no option to make mistakes.
Mm-hmm. And what are some common misconceptions companies might have about integrating embedded software into their products?
The thinking that it could be easy, because it's getting more easy, and that's the good news for our customers. It's getting much more easy to start. You can see from the do-it-yourself trend with products that maybe you heard about, Arduino, for instance, or the Raspberry. There is tons of kids now that they can interact with software. They can turn in a light while they just click on some buttons without having any knowledge of the languages that you need for that.
Okay.
So starting from zero, just doing a POC, a proof of concept, and so on, it's quite easy. And so you may think, okay, if it's so easy, I can go up to the production with that and having something that is good for the customers on the market for 10 or 20 years, which is not, unfortunately, the true. It comes with the fact that you have each time to go with the last mile, a kind of craftsman work, because each product has a different hardware platform with different electronic components. And so for each of them, when it comes to the integration, to the setting of parameters, you will have, unfortunately, I would say, a part, if you are curious, like embedded software developers, to go into the Bible of the components of the silicons, because in the 20 pages, you will know what is the register, what should be the right setting. to make sure that you can interact directly with the hardware. I try to simplify the things, to be honest, but that's just trying to explain you why there is some kind of complexity and the misconception that are coming from, it's easy to do that even at school now. So it means I can do that easily after also in the industry.
Yeah. And that's great. And you mentioned, of course, the first problem that comes up is that, if you make a mistake, then there's no connectivity, obviously. Do you have some more examples? What could actually go really wrong if you underestimate the challenges that come with embedded software?
It can go really wrong because the embedded software, I would say, is just the ultimate layer that you have in between the hardware that makes the things moving and what is in the code inside. And so you can imagine whatever the end product, this end product may not work as it was planned. It depends what is the product. If the product is a medical device and that the medical device is supposed to be on a body, and I mean, you can imagine whatever the cases there are, but depending on the features that are behind the product and how it does interact with his environment, it could be dangerous or just a simple failure that will not affect anything in the environment around. It could be critical. The origins of embedded software, and as usual, I would say most of the technologies are coming from aerospace, military, and so on. These technologies initially were mainly developed for the aerospace. And one of the most famous operating systems was coming from the aerospace at the time where they launched a rocket on the moon. It was something that started, in fact, where we did start to have some operating system in the machine and not only in the laptops.
Oh yeah, a lot of things can go wrong there. I can think of many examples.
Especially now with the future, where we have more embedded software challenges and developments right now in the automotive. Because we expect in the future we should have autonomous vehicles. So it means they should be capable not to make decisions, but at least to go in a way without any activity of a human body.
As you mentioned, challenges, what are some of the key challenges when it comes to integrating embedded software, for example, for automotive clients? Can you give some examples?
It's really about, at the beginning of the story, it's about selecting the right hardware. And that's maybe one of the reasons why we are part of Avnet, by the way, is because when it comes to building a new device, it's not like there is a clear split in between the brain and the body. And so imagine that the brain is the hardware and the body is the software, or the opposite. But there is no split in between both of them. You need the right combination of the right hardware with the right software, because you can take the most powerful hardware, it may not work with the software that you are willing to develop, and the opposite is also the true. So the main challenge that they have is making the good match in between the two. And it's like, for instance, if you are taking speakers with an amplifier, in fact, it's the combination of the two going to make the right sound. It's not because you are taking the most powerful of one of them that makes things that will work. And it's clearly the challenge that our customers may have, because they may start with the wrong assumptions at the beginning, saying, okay, I will take this hardware because I have the belief that my software will be supported by that. And after 6 months, they need to rework everything, because unfortunately, there is not enough capacity in the hardware to make the things that they expect. Other challenges, and again, I think that's the added value that we have with Avnet and this consultancy approach, bringing solutions to our customers with both hardware and software. It comes with the fact that there is technology gaps. Technology is evolving quite fast on the hardware and the software side. Our customers are not on a daily basis looking at the new technologies that there is on the hardware or in the software.
Okay.
And so we are coming here to bridge this gap, because we had the case 3 years ago. There was this shortage. So they had to change for the new hardware platform. We had to adapt, to make platforming, to adapt the software for different platforms. And it was a big challenge for them. And we have customers right now that are moving from a technology to another one, like moving from a microcontroller to a microprocessor. And then there is not the right software people in the company. You may have 100 software engineers that know how to work on the microcontroller. And now that you are moving to a microprocessor, there is no one in the company who can work on that. So Managing internally all these technology gaps and having the right resource for that is clearly also a challenge. And it's a bit of our bread and butter, and that's why we are still existing, I would say.
Interesting. You just mentioned something like cross-platform availability and scalability. So that's basically actually then also a new layer of challenges that companies have to be facing, well, now and in the future, or have been facing all along.
Simplifying the things. And I would say in the industry, I come from the automotive industry, and most of the product developments, new project developments that they have, 80% is related to what we say carryover.
Okay.
And what is the percentage of carryover that they bring? Because more carryover you have of a product from a previous product on a new project means less risky is your project. And no one in the industry is willing to take risks. So you try to get carryovers from previous projects to a new one to reduce the risk on your product development. And so by some extent, it's the same on the software. Trying to reduce the risk on the new development with taking some existing platform that are existing from previous projects. And to do that, it's all about platforming and trying to make, I would say, a maximum of bricks that may be reused from whatever the platform. Even if we come back to what I told you at the beginning on embedded software, very low level, there is always a last mile to do. But for the other layers, it's true that you can try to make bricks that you reuse from a project to another one.
Yeah, makes absolute sense. And I heard you say that the misconception with out-of-the-box solutions, that many believe that out-of-the-box solutions are ready for immediate deployment, right? But this is not the case with embedded software, is it?
Unfortunately not. Again, it depends if you want what you want. If for a prototype, for a proof of concept, for sure it pretty well work, but there is always some limitation. Unfortunately, you will have to go for some changes. What's happening in the industry now, I would say, when it comes to embedded, you have the choice in between three options, because there is always a part, even in the embedded, that could be reused or that can be common. There is commercial low level, but embedded still. Talking about operating system, so I would say the brain, the basics on the low level. You have an option of commercial operating system that are very black box, where everything is already prepared, so there is a lot. To make sure that it goes for all the cases, for all the hardware platforms, all the drivers, they will embed all the things. So it's not lightweight, so be careful about the memory that you have. But you can go for that. Unfortunately, one day you will need some changes, some improvements, and so you will have to go in front of the vendor and asking him for the changes. Depending on how big you are, he may treat you your demand in 2 weeks, in a month, in a year, or never. So that's the drawback of that. But there is some pros also for this approach. I mean, our customers are not stupid. If they select this option, it's because there is also advantages to that, but the disadvantage is the one that I mentioned. You can go also now for, I would say, 10 years, and it's more and more a trend, it's going for open source. Open source, what does it mean? It means that you will build a code with bricks that are existing from the community, and the community is engaged to maintain that and to make it changing, which is pretty relevant because, and against commercial distribution, the commercial distribution is coming from a company. The company could be alive still in 5-10 years, but maybe not. While the software that is coming from the community will survive maybe for 30, 40, 50 years, I know, but much more likely than a commercial operating system. And in between the two, there is commercial open source operating system, which is a bit the best of the two approach. This is companies that have built some bricks with elements, items coming from the open source, and that they are engaged to give you the access to this code. So it's not black box. It has been pre-built, and they are offering you this code that will be maintained by the community, but they did all the first steps for that. This is an approach also that we did develop something that is named the embedded kit, which are these bricks. It's a commercial open source operating system that helps our customers to make the first steps and so to accelerate their product development without being in dependency with us.
We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by AFNet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or afnet-silica.com. That's avnet-silica.com. Yeah, you mentioned the hype word of, I think, the next decade, artificial intelligence. How will that change the industry, bringing AI into the mix now?
It has already a bit changed the industry, to be honest. I think most of the audience have maybe already interact with Copilot, for instance. We have the same on the developer side. What does it mean and what you can expect, what we can dream? At least what we can see right now is Copilot is the right name in the sense that it's a code assistant. It will not create the code from scratch. It could, but first, we still don't know where is coming the source code that they are designing. So you could have some copyright issues, even if that is evolving. But it does not take into account all the complexity of the project. So again, it's more code assistant, meaning that you can start, if I am a developer, I start coding something, and then it's giving me an idea of what I could do after. So I'm saving time. Or I'm used to code because, on the developer side, it's like when you are in different countries, there's different languages. And so you are used to speak, I would say, in English, so in Java, for instance, and then you have to work in another language, but you a bit forgot. And so thanks to the code assistant, you're just typing the things and it's giving you an idea of what you could do or what are the rules to code in this language. So that is very helpful and powerful to save time and to improve your efficiency when it comes to coding. Something that we cannot replace is the creativity. I told you that in embedded software there is no creativity, but on some layers there is. It's about experience. It's about why you're going to be at an engineering school, being an engineer and looking at problems, trying to solve these problems. And so having a judgment on what you do. The common mistake that we may do about this AI software engineering, which is a big trend and that is coming, is that it could replace the developers. It will not replace the developers. And hopefully the young developers will take the time still to think about what they are doing before going with these tools. Yeah. When you're an experienced developer, using this code assistant, this Copilot is just great because you are really improving your efficiency and your performance. Or also, it keeps you some CPU. Even more CPU to think about what would be the right way to make the assembly of the puzzle.
Absolutely. And you can also automate some minor tasks, right? And let the AI take care of the quote unquote simple things. And then you have, as a developer, so much more time or CPU, as you said, to solve bigger problems or work on bigger tasks.
That's clearly the way it's going on. And there are some areas of software development, like in the cloud, where I would say before the AI, you had like 50% of the things that you had to do are copy-paste of language. Thanks to the AI, you don't need to do this copy-paste. So on the cloud side, developers are already saving a lot of time. I did had conversations with guys at Amazon that are already saying, I save 30% or 40% of my time because all this copy-paste, I don't need to do anymore. Yeah. On the cloud side. On the embedded, it's still limited and it will stay limited because all this AI, is based on models. So it's trained on models. It's easy to find models in the cloud area. In the embedded side, the code is more in the machine. So it's not shared with a community, so the models are not trained or may not be trained enough to be performing. Still, we will be there, maybe a bit in a different way for the low level. Even if I didn't mention that, but at Witekio, we do work on the embedded, but to some extent, IoT is also the application side, what we name middleware, which is still at the limit of in between the embedded and what is more in the cloud.
And I suppose it will also mean that engineers in the future will just also need to broaden their skill set, then work with AI and not only learn new programming languages or learn about new platforms, but have then also different skills that include artificial intelligence processes, right?
The engineers by nature, I would say, are curious. It's all about staying curious about what is changing. And there are, more than I am. Before discussing together, I spent 2 hours discussing with the engineers about what were the trends and so on. And they know even much better than our customers.
And you mentioned at the beginning of our conversation hardware partners. How does collaborating with hardware partners enhance the development process of embedded systems?
It's key because hardware, silicon vendors, what we say in our world, they need to seduce a bit the developers because the developers are part of the decision in the hardware that's going to be used. It was less the case in the past, and it's less the case in some technologies like on microcontrollers. And so they should make accessible the information about the hardware or make it more easy also to develop or to code. And you can see that in the sense that the silicon vendors are trying to bring some bricks, software bricks, what we name SDK, on the hardware that they provide, or tooling also, to help the developers to make their life more easy. That's a way where hardware companies, so the silicon vendors, interact with us. That's the first one, I would say. And there is trends, and it's very strange, by the way, what is happening right now. I don't know if you did follow the news. We're in a world that has been dominated 30 years, maybe more, by Intel. Intel were designing an architecture for the microprocessors. Then came with the IoT, a company that is named ARM, with a different architecture, bringing less powerful microprocessor on the market, but with lower consumption in terms of autonomy, and so much more relevant for devices that are connected on the field, small device, and so on. And now it was announced that Intel was willing now to sell its foundry. They are in a so bad situation, in fact, that now they need to sell the jewels, I would say. And ARM is going as maybe the potential also microprocessor for the future, not only for IoT, but for the servers. So it's really crazy how it's going, because on our side, on the embedded side, we started on x86 or on Intel with Microsoft, because both of them were pretty linked. Everybody knows that, because in the laptops it was like that. But on the embedded device, it was the same. When you are buying hardware that was with Intel, you had to buy, at this time, a commercial operating system that was Windows. That's where started our history, by the way, 20 years ago. It was just 10 crazy French guys. And they did develop because they were the unique partner with Windows to make the operating system, the Windows C operating system. And that's why we went to Seattle, opening the office and so on. So, but things have changed now.
Yeah, it's really interesting times at the moment in the tech world, isn't it? Now there's just so many fundamental things that have been taken for granted for the last 10 or even 20 years. And now all of a sudden with AI and new connectivity scenarios, things are breaking up and changing so rapidly again. It's really interesting.
Something that we do work also a bit, but it's about NVIDIA. Growing with the GPUs, and so you use it when it comes to AI. In the case of embedded, we name that Edge AI, because it means that you are doing the processing of the data inside the device and not outside the device. Because what is happening right now with AI, mainly the data processing is done in the cloud, so not on the product itself. But still, there is more and more cases, and that's all about innovation right now with our customers. They need to figure out, and are trying to figure out, what is the value of bringing the intelligence in the machine. There is some case studies, it starts bringing some value for the customers. It's a bit like IoT 10 years ago. Everybody was going in IoT. They didn't know why. But all products had to be connected up to the pillow. Everybody was going crazy with this innovation, not knowing what would be the value for the customer, managing even some new business model based on the data. Some did succeed, but bottom line is that IoT is no longer a trend. It's just common to have connected device. In some cases, again, the connected pillow, maybe no value for that. But otherwise, I mean, it's pretty common. And we are at this stage, I would say, with the AI in the device, AI, all the manufacturers, all the device makers, all of our customers, even if right now it's a crisis, they still have some budgets to explore what they could do with AI at the edge. Now, again, there is some cases though where it's works, especially with the video. I can give you an example without naming the company, but dash camera or body cam, they did embed edge directly on the cam because it makes it much more easy for the police to make the report. In fact, based on the video, the report is done directly. And so they don't need to connect the device, being back at the office and so on. So there is a clear example. Otherwise, also, everybody knows about the drones and so on. So again, in the military, aerospace and stuff like that, where you need to process the data quickly on the device. But for the others, what is 90% of the market and of our customers that are doing home appliance, that are doing medical device and so on, they are still exploring what they could do. Because you can do that on the cloud. Why should you do that directly on the machine? Still question mark, because in fact you need to imagine the features that you may create with that. But the customer does not have the need because he does not know that he could do that. It's like at the time of Ford, if we ask Ford what would be the best new car, he would say a car with 4 horses. I mean, that's where we are.
Yeah, I can imagine that especially clients from the medical industry would have a tremendous benefit from these solutions. Can you share some use cases or maybe even a success story without naming the client, of course?
We have one use case right now where I cannot name it, where they are using the AI at the edge, at the microcontroller side and on the microprocessor side. On the microcontroller, microcontroller is something that is determinist, meaning that it makes a decision every time more or less the same. If you ask him 1 + 1, it's going to be 2 after 2 seconds. It will be always like that. It's used for the security. We did integrate that on the microcontroller to make sure that there is a check if the device was working properly inside in the hardware. So it means that it's an ultrasound device to check in the ears. It's a handheld device by definition. There is always the check that is done internally thanks to the AI on the MCU. And on the microprocessor, the microprocessor is the much more powerful used to turn the ultrasounds into results. That can be done thanks to the AI that is locally. So it means that your device, there is a screen on the device, and directly just by magic, I would say, they can tell you if there is something wrong. While if you didn't get that, you should have a device that is not handheld. You know, it's a bit the same like for the mobiles. First mobiles, they were not so handheld. And the first one to use that were physicians in the urgency and so on. So when you had a case in the street and so on, so they had this mobile. This is the same with this kind of device. And so for the medical industry, the first application going to be for people that are not in an office. So it means for urgency and case like that, and they can make quickly the check without being connected and so on. So you can see there the added value, and it's easy to explain to your investors why you should do that.
Very cool. What advice would you give companies or your clients? How would they best leverage the potential that they now have at their fingertips with all the innovation that's coming our way?
The same as for any kind of innovation is don't go directly with clear requirements and product that you believe that should be the one that's going to be in 5 years. Go into an iterative approach, meaning start with the proof of concept, I would say, or the prototype. See how this prototype interacts with the end users, the environment, and go into loops to make the things changing, because you're going to learn about the technology, you're going to learn about the usage during all these phases. If you go for a stage gate process, stage gate meaning I define the requirements, I go into the development until the end. That works pretty well with a carryover, with a technology, and with a usage that you definitely know. That will be like that. But for when it comes to innovation, you have to go with an iterative project where you accept that you don't know what's going to be the product at the end. So, my advice would be don't spend too much money first. Do a first step and then iterate if it's worth.
That's great advice. Thank you, Nicolas. It has been fantastic having you on the show, and thank you so much for sharing your insights with us. It's clear that software is not a commodity, but really a key asset that requires careful consideration and expertise. And you really brought that value to our show. Thank you so much.
Thank you, Ruth.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.